we have learned Gauss's law and we have derived a formula for flux using Gauss's law. We also have the formula of flux by the definition. So let us first write those formulas. Okay. So phi equal E arrow dot delta S. This is the formula of flux by formula, and this is the formula of flux by Gauss's law. Now moving further, today we shall understand and derive the formulas for application of Gauss's law for few cases. Okay, so let us talk about the first case in which we are considering field due to an infinitely long, straight, uniformly charged wire. Now here this is a question. Every time whenever there is a derivation in physics, either the heading is a question or its derived formula is a question. Remember that. It simply means that we have taken a very long straight wire which is uniformly charged. What is the meaning of the word uniformly charged? That means the charge distribution on the whole wire is the same. If you consider one particular portion of the wire, then the charge in this portion is same as the charge in the another portion. Okay. Now, for deriving the field, let us consider the cylindrical Gaussian surface around the given wire, which is very long. But our Gaussian surface is covering only one portion of the wire which we have taken. That is the meaning. Now Gaussian surface is of cylindrical shape. That's why it can be considered of a length L. Again I am rewriting. This is a diagram from the textbook itself. I have taken it from there so that you can connect with the textbook. Connecting with the textbook and formulating from there is very important for any exam of entrance or the board. Fine. So this is the diagram from textbook itself, where L is the length of the cylindrical Gaussian surface which we have considered, and R is the distance between the wire and the point P, where we have to or we want to find out the formula or the value of the electric field. So this wire which we have considered, let it have a linear charge density of lambda greater than 0. Now what is the meaning of lambda greater than 0? It means that the linear charge density lambda has a positive value. If I write lambda less than 0, then lambda is having a negative value. Fine. Now what is this linear charge density? We will just go into its formula and a short definition. Okay. Linear charge density lambda is equal to the charge in the portion which we have considered. Let us write it as Q. Let us consider that the charge is Q from this surface of the cylinder to this surface of the cylinder of the Gaussian surface, covering this much length L, length of the wire. So divided by L is linear charge density of that portion of the wire. So lambda is the ratio of the charge contained in that portion of the wire which we have considered divided by the length of that portion of the wire which we have considered. So its unit is coulomb per meter. Okay, fine. So we shall use it for our further formula where we can substitute Q is equal to lambda L. Fine. lambda L. Now our aim is to find out the electric field at the point P. So let us use the formula number 1 for the flux through this surface. So what is this formula saying us? Phi is equal to E dot S or delta S, whichever portion we consider, which is equal to Es cos theta. Now we have to understand what is this cos theta for the given situation, or what is this theta for the given situation. Now here any cylinder we can consider as three surfaces. Surface number 1 the upper portion, surface number 2 the lower portion of the cylinder, and surface number 3 is the curved surface of the cylinder, and our point is on the curved surface. So theta also will be between E and area element for the curved surface only. So to remove the confusion, what would be the direction of the electric field and the area element for the surface 1 and 2? Let us draw it and let us understand theta for both these surfaces 1 and 2. So we can consider the direction of the area element, say S1, which will go perpendicular outwards as per the rule of the direction of area element from the surface. And because this charge is positive, the rule says that the electric field direction will be outwards, radially outwards from the charge. This can be considered like one plate. So the charges can have the electric field radially outwards, and this is one of the radius which I have drawn. So what is the answer, or what is the theta here? Theta 1 is equal to 90 degree. Cos 90 degree is 0. So anyway, flux through this surface is 0. Similarly, flux to this surface, this is the direction of H2, area element. Similarly, this is the direction of electric field for this surface. So what is the angle theta 2? 90 degree, cos 90 degree is 0. So the flux through this surface is also 0. Now we have the curved surface area. Because the charge is positive, the direction of the electric field will be radially outwards from the point. And for this surface, the direction of the surface, I'll write it as simply S, will also be radially outwards as per the rule for the direction of the area element. So what is the angle between this E and S? Theta is equal to 0 because the direction of E and S is same for the curved surface area, surface number 3. Fine. So here I can write theta is equal to 0. What is cos 0? 1. So what is my answer here? ES. So phi is equal to E S cos 0 is 1. Now what is the value of S? S is the curved surface area of a cylinder. The cylinder has the radius R, length L. So what is the curved surface area of a cylinder? S is equal to 2 pi RL, which is the curved surface area of the cylinder, which I can substitute here and I can write phi is equal to 2 pi RL E. Fine, E I have written in the front so that there is no confusion. So E 2 pi RL. This is the curved surface area of a cylinder. Fine. Okay. So let me name this as equation number 1. Now let me use the equation number 2 for the flux through this surface. So what is, I have already named it as equation number 1. So I will name this as equation number 3. Okay. So now what should I use? I am using the equation number 2 for flux. What is it? Phi is equal to Q upon epsilon naught. What is my Q as got from here? Lambda L. What is lambda? Linear charge density greater than 0 divided by epsilon naught. So what do I get? I get equation number 4 for flux. So equating equation number 3 and 4, because they both are flux, one using formula and the other using the Gauss's law, we can equate them and we can write E 2 pi r L is equal to lambda L upon epsilon naught. L and L I can cancel out because one is on the LHS side, one is on the RHS side. I am interested in the electric field at the point P. So E at the point P is equal to lambda left out here, and I bring this portion 2 pi r down and I have epsilon naught also. So this is the notation or formula for the electric field at the point P on the curved surface of the Gaussian surface cylinder which we have considered, which is at a distance r from the uniformly charged infinitely long wire. Clear? Okay. Now, if I want to write the vector notation of this formula, I can write E arrow, which is a vector notation because you can see that E is you know that E is a vector. So, E is equal to lambda upon 2 pi r epsilon or r constant for a particular situation where I have taken the Gaussian surface of radius r. So, it is going to be constant for this situation. So, how do I understand the direction of E? By n cap. What is n cap? For lambda greater than 0, n cap for lambda greater than 0 will be radially outwards. So if lambda is less than 0, then the direction of the unit vector will be radially inwards from the point P. That's it. Okay. So you understand this particular derivation. This is our first application. In the second and third application also we are going to follow the same process. So if this is understood, the other two processes will automatically be understood by you for the other two applications, for a thin sheet and for a shell. Okay, what is the process? Just go through it. That we have considered two formulas of phi, one by formula and one by Gauss's law. First we understood or we substituted phi for the formula and got equation number 3. Phi with Gauss's law, we got equation number 4. We equated them, we got the electric field at the point P, away at a distance r from the wire. Fine. Okay. So I will just move. You take a pic of whatever formula is derived for the electric field, and we will go to the next section for understanding the graph of the electric field with the variation of the distance of the point P from the wire. That means variation of r. Fine. Okay. So now we move to how to draw a graph for the electric field we just now found out, which was given as E is equal to lambda 2 pi epsilon naught r. Now here, as you can see, this portion 2 pi epsilon naught is a constant value. Lambda is also constant because we have taken wire with fixed value, but the distance between the wire and the point P is changeable because the Gaussian surface was selected by us with a particular radius. So as you can see here, E is inversely proportional to R. So if I draw a graph of this particular variation, then what do I get? Or sometimes it is also shown as, okay, sometimes it is also shown as a direct graph. Now here, whenever there is graph, you should be very careful of what is on x-axis and what is on y-axis. That is very important. Here on the y-axis it is E. You need not write the direction also. And here on the x-axis it is R. And read here, E is inversely proportional to R. So it is inversely proportional, so it should be a negative graph. Okay, so now how do I go? I go like this with the curve. It is a negative graph but with little bit of a curve in it. Now they can also ask you a graph of the same. So there the confusion can arise that what is the x-axis, what is the y-axis. So again I write the x-axis here as E and here the y-axis 1 upon R. So I can read this as E inversely proportional to R. That's why I have drawn this inversely proportional graph. Here I can also read as E is directly proportional to 1 upon R. I can read it like that. So very important it is to understand what is there on x-axis and what is there on x-axis and what is there on y-axis when the graph is asked. Whether it is in the board or JEE or NEET, such graphs are asked. They can give you whatever on x-axis and y-axis, but they can change the shape of the graph. So because I have read it like that, according to the given on the x-axis and y-axis, what should I read? E is directly proportional to 1 upon R. Directly proportional. How do I draw the graph? A straight line. Okay. So it should be a straight line. Fine. Okay. So here I draw a straight line graph starting from the origin. If at all the x-axis is 1 upon R and y-axis is E. It will be a curve if x-axis is R and y-axis is E. Fine. So these two variations can be asked and possible according to what they have given on the x-axis. Y-axis remains the same as E and E. So I just move here and you take a pic of what we have learned just now. Okay. This formula is for a wire which is uniformly charged and infinitely long. Fine. I had this formula also. I just move, take a pic.